A Ferris wheel has a radius of 18 meters. Let's go ahead and draw this real quick. I am not an artist, so there's our Ferris wheel. And of course it's being held up. Let's pretend it's being held up like that. And our radius is 18 meters. So from that middle point down to the very bottom, okay, that's 18. Or from that middle point up to the very top is 18. And center C, that's this point right here, which is 20 meters above the ground. That means that since we know our radius is 18, we know that right there is 2. Okay, and of course from there all the way down, that's 20. Platform allows a passenger to get on the Ferris wheel at a point P, which is 20 meters above the ground. Okay, so that's up here, kind of at the same level as C. So let's just say that the platform that they get on is right here. Okay, and they get on there. And the ride begins at that point when time is t equals 0, and the passenger starts by traveling downward. Okay, so they start by going this way. We want to find a function that models the height above the ground of a passenger after t seconds. Let's go ahead and draw a little picture here, and I'm going to kind of just line it up with that so we can see it. Here's our equilibrium, and our equilibrium is up at 20. Okay, we've got our 0 down here. That's going to be our t-axis. They get on there, and they start by traveling downward. And they travel downward, and then of course they're gonna turn around and come up, and then get back to where they started. And it says that the Ferris wheel rotates once every 32, it doesn't even say, but we're going to go ahead and assume seconds here, 32 seconds. So over here is at 32. So this is what we're trying to model here. And we see that our midline equilibrium here is up at 20. And our period is 32. So we know that, first of all, because we start on the midline, we're going to work with a sine function here. Kind of our most general form is y equals a times sine of b t minus c plus d. Now, because it starts at t equals 0, we're going to say that c is 0. Okay, there's no shift here. So c is going to be 0. A, I'm going to say is, well, that's of course the amplitude. That's the total distance from the midline down to the minimum point, which is that radius of 18. Okay, but because I start by going down, I'm going to go and put a negative there, because normally the sine function starts by going up. Okay. To get b, we use our period. 2 pi over b is the period of 32. So we can solve for b there, and we get pi over 16. And d, of course, is the midline value, and that's up there at 20. So our function is y equals negative 18 sine of pi over 16 times t plus 20.